everyone, today we're going to be solving equations using our multiplication principle. So let's start with our first example. If we look at example 1, we have 5x equals 70. So we know that a coefficient next to a variable means multiply. So 5 times what number gives us 70? Well, one of the ways that we can undo this is by doing the opposite of multiplication, which is division. If I want to isolate my variable, that x, I know it's being multiplied by 5, so if I divide by 5, it's going to cancel everything out. And whatever I do to one side of an equation, I have to do to the other. So I'm going to divide that 70 by 5. 5 divided by 5 is 1, or because I don't really need a coefficient of 1, I can just put the x there. And then 70 divided by 5 is going to be 14. So we know that x equals 14. If you notice, I have example 1 over here again. Kind of looks like a weird 5, but it's a 5. So if we look right above it, it says multiplicative inverse. So what we did here was we divided the equation by 5 on both sides for this left side. On the right side, we're actually going to use the reciprocal. So if I have 5, what's the reciprocal of 5? Well, 1/5, or 1 over 5. So I can either divide or I can multiply by the reciprocal. And whatever I do to one side of an equation, I have to do to the other side. So I'm also going to multiply my 70 times 1/5. Over here, we know reciprocals will multiply together to give us 1, so I'm left with 1x, or just x. Over on the right side, if I go ahead and I practice my fraction multiplication, I can just go through and get 70 over 5. It's actually what we had on the first equation that we did. And we know that 70 divided by 5 is going to be 14. So regardless of if we use the opposite operation, division, or if we multiply by a reciprocal, we're going to get that same answer. And we can use either way as we go through solving the other equations. So let's go ahead and look at example 2. Example 2 is negative 4x equal to 92. So again, what I'm going to go ahead and do is start by making my line to separate my left and right side. And since I like the division a little bit more, I'm going to go ahead and divide both sides by whatever that coefficient is. So our coefficient is negative 4, so I'm going to divide a negative 4 on both sides. If we remember, the negatives will cancel out from our integer division, and the 4's divided by 4 will equal to 1, so we're just left with 1x, or x. And then we have 92 divided by negative 4. First of all, again, from integer division, we remember that a positive divided by a negative will yield a negative answer. And 92 divided by 4 is going to be 23. So we have that one. The next example that we're going to look at, example 3, is negative x equal to 9. So this one's a little bit tricky. We've been talking a little bit about this as far as for the answers, but we don't really ever see it in our original equation. I don't see a coefficient here like I did with my 5x on example 1 and my negative 4 with example 2. So I have to put a coefficient here. Our coefficient, whenever we don't see it, is going to be that invisible 1, or the 1. So I know that I can divide both sides here by negative 1. The negatives will be gone because a negative divided by a negative is a positive. And 1 divided by 1 is just 1, or we're left with x. On the right side, we have 9 divided by a negative 1. Again, a positive divided by a negative is going to be a negative, and 9 divided by 1 is 9. So we're just left with x is equal to negative 9. All right, let's move on down to example 4. If we look here at example 4, we have the fraction 3/8 equals to negative 5/4. So before we actually complete this example, I want to go back up to that example 1, the second time we did it, using our reciprocal when we multiply. It was so important that we used it here because we needed another way to solve it. I'm going to take that idea and I'm going to use it to help us solve example 4. Since I'm working with a fraction, I know I can get 1 by multiplying by the reciprocal. So the reciprocal of -5/4 is going to be -4/5. And whatever I do to one side, I have to do to the other side. So I'm going to multiply that left side by -4/5 as well. Again, we have to remember our integer rules. When we are multiplying, a negative times a positive is a negative. I'm going to go ahead right now and just multiply straight across to get 12/40. We're going to simplify in a second. On the right side, we know that anytime we multiply a number by the reciprocals, it's going to equal 1. Or if we cross reduce before we multiply, we can cancel out, and we're just left with 1x or x. At this point, we have to remember that we need to always simplify our fractions. 12 and 40 are both divisible by 4. So I'm going to divide them both by 4 and get -3/10. Once my fraction is simplified, we finally have what x is equal to. Okay, moving on to our last example, which is negative y over 9 equals to 14. So with all of our other examples that we've looked at, we were multiplying our variable by some number. That's why we had a coefficient. Here, we're dividing it. So we have to think to ourselves, what will undo division? And what is the opposite of division? That's right, multiplication. So I'm going to go ahead and I'm going to multiply both sides by 9. That's going to get rid of the 9's on the left side, and we're left with -y equal to 14 times 9, we know, is 126. And we're almost done because now this looks very similar to example 3 right above it. Remember when we had that -1x? Well, first of all, we have to put that invisible coefficient here of 1. And now, all I need to do is divide both sides by a -1. The negatives are gone. 1 divided by 1 is 1, or 1y. A positive 126 divided by a -1 is going to be a -126. We've isolated y, so we are finished. Yay! All right, the last thing before you guys are finished is for you to try these 8 problems on your own. So I'm going to give you guys a little bit of time to copy them down. Take a moment and pause the video, and then let's see how you do with solving equations. So here are the answers we got from 1 through 8. How did you do on these? Solving equations does take practice, so make sure if you're not understanding it, you're going back through and resolving them.